really kind of four ways people get better. One is there's something called diaskesis. So what diaskesis is because the brain is connected, areas that are undamaged because of their connection to damaged areas become dysfunctional. And so over time, as the brain heals, those undamaged dysfunctional areas regain their function. That's one mechanism. Another, which is called restitution, is, and this is kind of what rehab is built on. So you have the direct damage to structures in the brain, which is the brain cells. By repetition, rehearsal, doing things over and over, those damaged areas and damaged cells can restore function over time. They can build up their synapses, the connections between the neurons. A third mechanism is through redundancy. So the brain has these built-in redundancies where you have a part of the brain that's primarily responsible for a particular function, and then another area that's typically surrounding that has a secondary role. It plays a support role. The primary area is directly damaged. That surrounding area can sort of assume some of the responsibility. And then there's the fourth mechanism called vicariation, where an area of the brain that didn't actually have a role because of neuroplasticity starts to assume that function. It's not able to do that at a level that would approximate what the primary area originally did, but it can provide some support, and the person can regain partial function in that area. When the brain is injured, it has these built-in mechanisms of recovery where brain function basically on its own can be restored, independent of any interventions that we do. Because of this global connectivity, there are certain regions of the brain that are interconnected with other regions. So the cortex has deep interconnections with the thalamus, for example, this deeper structure. And these bidirectional connections keep the brain in a sort of homeostasis, a fluid means of functioning and processing information. But what that also infers is that if, for example, the cortex is damaged, these excitatory or activating inputs from the cortex that act on the thalamus are diminished. And so then we can have a disruption in brain function. Even at the thalamic level, it can't do its job because it's not getting the right inputs from the higher levels of the brain and the cortex. But it can also be the reverse, where if the thalamus is the seat of the damage, and the cortex is relatively well preserved, and that can happen if somebody has stroke or some more focal type of injury. What happens is that because the cortex is dependent on that thalamic function, if the thalamus isn't doing its job, it's not going to excite or activate those downstream cortical areas. And the cortex is the seat of all higher thinking abilities, memory, attention, problem solving. So what it leads to is a situation where we have these viable cortical areas, meaning they're preserved. They can still function, but they're not turning on because the switch isn't being flicked from the thalamus. So one way to for the brain to restore function is if the thalamus begins to reactivate, then it can drive cortical function again, which is preserved. There's no damage to those regions of the brain, and they can reassume function and restore function.